everyone. Thanks very much again for joining today's webinar. Today I'm pleased to be joined by Ian Redpath, Principal Analyst within our Intelligent Networks practice here at OVUM, and also very pleased to be joined by Gilad Preminger today, who's Head of Cloud Networking Solutions at ECI Telecom. Just a couple of housekeeping points before we commence the presentation. We are recording today's session, so you will receive a copy of the recording and the slides to your inbox within 48 hours. And secondly, we shall be having a Q&A session at the end of the presentation, so please feel free to type all your questions in the chat box on the right-hand side of your screen, and we'll aim to get round to them at the end of the webinar. If we don't get round to answering them, we shall follow up via email. Thanks very much again for dialing in, and I shall now hand over to Ian, who will commence the webinar.
Thank you, Lucy, and thank you all for dialing in and listening today. I will launch into our first presentation on how optical networks are evolving in support of the growing data center interconnect requirement and the growth of cloud services as well. When we think about networks and network growth, we often think about end user demands and needs first. None of that growth would actually materialize without a corresponding investment in network and network resources. And there's always a constant push-pull between the demand side and the supply side of network. So I'll begin with the discussion with a bit more of a supply side view of network evolution. So OVUM has been tracking the data center market for a number of years now. We're tracking from many different perspectives and measuring different metrics. First off, the data center world continues to build at scale. Many folks are well aware of all the cloud provider data center builds to date, but it's going and it's continuing strong in 2016 and 2017. New data centers are being commissioned in places such as Dublin, Ohio, Arizona, Montreal, Athenry, Viborg, Chonburi, Ningxia, Hokkaido. Around the world, it's a global phenomenon. And more cloud providers are adding web-scale size data centers to their global footprint. And some of these new additions are bigger than anything that we've seen to date. So this involves billions of dollars of capital expenditure. It's resulting in millions of square feet of data center space added every year, which is populated with millions of servers. And the servers inside the data centers are interconnected to each other with thousands of optical transceivers. And a portion of the intra-data center traffic exits the web-scale data centers, and that's the inter-data center market. And so they're connecting to other data centers, and they're also connecting out to the client community. And so as the internal intra-data center traffic grows, so does the external data center interconnect requirement grow as well. So, and the scale that we're talking about is terabits quickly and rapidly evolving to petabits of LAN traffic for data center interconnect. And another major supply side factor that is really just upon us in 2016 is the beginning of a major technology transition inside the data centers. So the cloud providers are looking at a major step up in scale inside their new and existing data centers. Starting with the servers, we expect server ports to transition from 10 gig onto 25 gig Ethernet. And in terms of the server density per rack, in some cases, we've been at 32 servers per rack, and we're looking to rapidly scale up there to 192 servers per rack in some cases. So a 6x or more increase in the server count per rack. And these two changes will catalyze further downstream changes. So the intra-switch fabric links were at 40 gig, and they will transition to 100 gig. And as everything inside the data center grows, then it flows through to the WAN traffic as well. Additionally, we expect this new greenfield, the new data center architecture to go into the greenfield data centers, but in time we also expect this to be retrofitted into the existing stock of data centers as well. And we expect this to help we expect this to happen at a web scale pace. So more and more data centers are being added to the global stock, and we're also looking at really a major bandwidth inflection point to go along with that. I see we're having a little bit of trouble with the slides. There's a little bit of cutoff to the right side. Hopefully that gets corrected as we go. If you can, let's advance to the next slide as well, please. Okay, so the next view is the data center interconnect market itself. And just proceeding around the chart, I'll work through the global, the national, and down to the metro. But what we're seeing as this market continues to develop is there's many, many different manifestations of data center interconnect. So in the upper right, we do have a global view. So many of the cloud providers are global in scale, and they're interconnecting the data center properties via global networks. And as a new data center is added, it adds a new node to the network and increases their global network. And then additionally, these global DCI networks are evolving. The cloud providers are opting for lower latency options when that's available, and they're also adding more diverse paths to increase the robustness of their network. And as well, the overall bandwidth in between those data centers continues to grow. The national data center interconnect picture is also evolving rapidly as well, too. So national, and then in some cases we have national, in some cases we have really multi-country regional networks. But they both started with a pretty basic configuration of a modest number of core data centers that were intended to cover areas. And what's really been going on lately is the extension of these core only to a core plus distribution. So new terms are coming into the industry, edge nodes and edge cache data centers. So that's what I'm intending to pick here with the little red circles. So that's the data center footprint extending into a distribution scenario with edge cache nodes. So the edge cache nodes place resources closer to clients to minimize latency and optimize performance. And the edge cache nodes don't necessarily need to be completely wholly owned. They could actually reside in a third-party data center. And we're seeing edge cache nodes also extend, from the largest cities out to smaller cities to create a more and richer footprint for the cloud providers. And then finally, we have the metro situation, and I'll talk you through the graphic that I have, right? The metro situation, what I have here is a depiction of the San Francisco Bay Area, a well-known area for all in the industry. And, what we've seen here is the large cloud providers have outgrown, the case where they have one data center only in their major metros. In cities with space constraints at the initial data center property, and high property costs, they've evolved into a 2, 3, 4, and so on data center per city. And again, due to the ability to acquire property and whatnot, some of these data centers end up being some distance apart, but these multi-site operations still require connectivity. And the dynamic that we're catching now with this is, evolving from a rudimentary point-to-point connectivity, moving on to a full mesh type of connectivity. And these cases, truly have the potential to grow into petabit scale networks. I apologize with the ongoing challenge with our charts. Actually, they're looking a little better now. We're getting a little bit more of the right-hand side. And I'm on to the next chart, please. So OVUM has been tracking the optical data center interconnect market and its impact on the optical equipment market as well. So starting with the pie graphic, the WDM equipment market is a $10 billion plus market today. And of that $10 billion, almost a third is dedicated to the application of data center interconnect. And then moving over to the Canada forecast chart, we expect the optical DCI portion to grow at a robust pace. So a 10% CAGR through our forecast period, which is outpacing the overall WDM market. So the data center interconnect application is becoming an increasingly important part of the overall WDM market. And you can also see here we have it segmented by some of the major buying entities. Communication service providers, of course, are obviously major buyers of the optical equipment that's going to support data center interconnect. And then there is also some equipment is going direct to some of the other entities. So enterprises, government research, education, and the cloud providers themselves all do acquire some of the equipment to build out the market. And so it's a pretty fast-paced market. And the other thing that we're seeing is new requirements, sharpened expectations for data center equipment. So, and this is something that the vendors are paying close attention to and aligning to some of the new market priorities. So, with the bandwidth expected to continue to scale dramatically, a compact footprint is highly desirable to minimize the overall space consumed. And then power consumption is a major data center operational cost. So minimizing power consumption is high on the priority list for the data center operators to help manage their long-run operational costs. And then today's data center interconnect market is 100G centric right now, but the beyond 100G market has already begun. We already saw shipments in that area in 2015, and we expect more there as we go into 2016 and 2017. OVUM expects 400 gig solutions to make their way into the market in the very near future. And another dynamic that will continue to be an incentive for that is in cases folks are fiber constrained, and whenever folks are in fiber constrained situation, they always do want to maximize their spectral efficiency, which helps with the push to higher and higher data rates. Okay, moving on to the next slide, please. So just kind of shifting gears here a little bit and moving on to more of a cloud service discussion. So OVUM is tracking the cloud service market from a number of perspectives as well. So one measure is the revenue performance of the major cloud service providers. The chart on the left highlights recent revenue performance out of a couple of the really bellwether organizations here, Microsoft and Amazon. So Amazon Web Services just reported a 70% revenue growth in 2015 over a year ago, 2014, bringing that business unit up to $7.8 billion annually. And Microsoft Commercial Cloud is also reporting similar growth rates, and that category is up to a $9.4 billion business. So it's the growth rate is what's impressive there, and it's an indicator of ongoing momentum in this market. Also on the right here, I have OVUM's most recent enterprise cloud service forecast, already a sizable market, and it's projected to continue to grow briskly through the forecast period. So the growth projection here is underpinned by a couple of dynamics. More and more organizations, crossing the threshold of using cloud services, and then within organizations, more take-up of more applications, more workloads per organization. So as the enterprise comfort level with cloud service grows, they move from the very basic routine and on to considering more mission-critical types of applications. But the enterprises do have some concerns. Acceptance in general is growing and the momentum is there, and I'll come to a couple of their concerns in the next couple of slides. So on to the next one. Yes, so cloud services are gaining budgetary momentum. So as part of our Enterprise Insights program, OVUM conducts an annual survey of enterprise ICT decision makers. Our last survey targeted enterprises larger than 250 employees in developed and both rapidly developing countries. So we survey just very quickly, U.S., Mexico, Brazil, UK, France, Germany, Italy, Turkey, South Africa, Russia, India, China, South Korea, Japan, and Australia. So the next series of charts highlight some of the pertinent findings from our last survey of the 2,700 ICT decision makers. So are they inclined to spend more budget? And the answer was a fairly resounding affirmative. They intend to spend in both our categorizations here, increasing the cloud service budget in the 5 to 10% range and 10% and beyond. So it is an increasing part of the ICT budget. And then advancing again to our next slide. What are their concerns? Again, we do have the momentum, but we're also probing for what are the remaining inhibitors from further adoption and even broader adoption. What are the remaining challenges, and how can the vendor and carrier community continue to help? So a number of the capabilities were ranked both very important and critically important. The question was, what are the additional capabilities in making a provider more attractive to you? And two types of security concerns were ranked pretty high. Both enterprises desire to see more managed security solutions, and then they also articulated the need to, and the desire to have a more secure cloud interconnect to their major cloud partners as well. Rounding out the desires, they also mentioned, looking for acceleration technologies to help reduce latency and reduce bandwidth costs, and they also vocalize the need for end-to-end performance monitoring for both the cloud service and the WAN service. So, to sum on this chart, enterprises are concerned with security, performance, and cost, of course. And then moving on to the next. So there's two questions on this particular slide. So on the left, and these questions were for the enterprises, but talking in context of their cloud infrastructure provider. So, where would you desire additional value from your cloud infrastructure provider? And we did get a number of responses here, but jumping down and focusing in on one and singling it out, the desire for end-to-end performance across both the network and the cloud, which it's a simple statement, but implies many different things in terms of provisioning and visibility. But that's highly important for enterprises of their cloud providers. The second question, which again I apologize, it does appear to be a little bit truncated on the right, but it's to do with loyalty and retention. How best to hold on to the customers that we do have, and the response that we got was, performance is more important than even pricing. People do want a high degree of performance. So, one of the takeaways that bubbled up for us here is really the whole issue of performance and the mating or bonding of the network service and the cloud service together. They need to be, and enterprises are increasingly viewing them as one integrated service that does need to perform and operate as one. So just transitioning on to the next slide. So the question here was to enterprises, what are the most important benefits of SDN? And what I wanted to highlight out of this question and the enterprise's responses here was really the desire identifying and wanting the variable bandwidth. So it did come out in a couple of points. They did want variable bandwidth, and then they wanted it in concert with a new usage-based billing model as well. So it's really, we use the term SDN, but what do you want out of your next generation network? And I think an important thing to keep in mind is, one of the things that the enterprises are really hoping for here is cost savings, which, it's a key point from the enterprise point of view. And they're hoping that, flexible bandwidth and a flexible usage-based billings construct will aid them there. So, that brings me up to my concluding slide. So when we look at this, we really see, two classes of opportunities for the communication service providers. There's really, the classic bandwidth opportunity, and when you track the growth of the market here and the extension in terms of properties and geography and the ongoing bandwidth growth, there's an ongoing opportunity to supply to this community, and it does continue to get further and further out into the globe. And then the new opportunity is really the whole concept of a tighter integration with Cloud Connect services. So, bonding with the cloud service, enabling a rapid turn-up, and then if it's desired, a turn-up, and also decommissioning at a quick pace. And so it leads folks to think, well, how can we differentiate in this arena? And, a number of different avenues for differentiation can potentially be, on-demand provisioning, and as I mentioned earlier, end-to-end visibility and control in this environment. Security is absolutely central in terms of expanding this market and broadening the addressable market, and commercial flexibility as well. And this is something that the industry is working on in terms of new models and new pricing paradigms. So with that concludes our opening presentation here, setting the scene for ECI, and I'd like to hand it over to Gilad for your views and insights on the market. Gilad, please.
Thank you very much, Ian. I will discuss in my part some of the challenges that service providers are facing in the cloud ecosystem and how they can overcome them and transform these challenges today to opportunities, and by that raise their business customer satisfaction and develop new revenue opportunities. But in order to do that, they have to change and adopt new services models. And I will discuss what are these changes. So let's start by a short reminder of why business customers are moving to the cloud. The main driver is flexibility. We can see in this survey that business customers mention many reasons in the flexibility area, like agility, scalability, mobility, and innovation as their main reason for moving to the cloud. And even the cost reduction benefit is achieved due to the pay-as-you-use model of the cloud. So it is really all about flexibility. And indeed, the business customer enjoys this flexibility in all cloud platforms, the infrastructure as a service, the platform as a service, the software as a service, and more. The customer can order these services and get them within minutes with the cloud pay-as-you-use model. We can see, for example, in this slide, the Amazon Web Services offering, where the customer can choose between several purchasing options, reserved for his ongoing usage, and on-demand spot for his bursting needs. And the customer can also mix different purchasing options and enjoy full flexibility. But the cloud is not an ideal place. There are some gaps in the cloud ecosystem. One gap is the network. The network flexibility doesn't match the cloud flexibility. With cloud services, the customer can order a new service and get it within minutes. But when it gets to the connectivity, it takes days and even weeks, in most cases, to provision a new line or upgrade existing one. And the same goes for the payment model. In most cases, customers cannot enjoy the cloud pay-as-you-use model with connectivity services. So there is a gap in the user experience that impacts the customer satisfaction from cloud services and doesn't allow the business customer to enjoy the full promise of the cloud. And the second gap is the security. In all researches, business customers mention the security factor as their main concern when switching to cloud services. So service providers must come with a solution for this concern in order to remove this barrier and by that increase the cloud adoption. But we can view these two gaps as two major opportunities for service providers. They can offer new two services in the X as a service concept. The network as a service offer flexible cloud connectivity as a service, and the security as a service offer complete security solution as a service. With these two new offerings, service providers can close these two gaps I mentioned and raise the business customer satisfaction. But not less important, they can have two new revenue opportunities. And I want to emphasize that I'm not talking about a future promise. I'm talking about solutions that are available, and I will show how we can offer them today. And before I dive into the solutions, I want to emphasize that when I'm talking about service providers, I'm referring to several kinds of them: internet content providers, data center operators, communication service providers, managed service providers, and others. All these players are seeking for better solutions to their business customer, to raise their customer satisfaction, and to find new revenue opportunities. These service providers will be happy to have the opportunity to offer the network as a service and the security as a service to their customers with the same user experience as cloud services: simple ordering from customer portal or API, providing the service immediately with the cloud pay-as-you-use model. So let's start with the first challenge and opportunity, the network flexibility challenge and the network as a service solution. It will be clearer to view the challenge and the opportunity with this slide that compares the current situation of the connectivity services and the network as a service approach. First, the network as a service changes the whole service nature from a fixed, predefined service to a dynamic, flexible service. The order process becomes much more flexible and even automated with network as a service. From a manual phone call or mail that is being handled by a manual provisioning process, we are adapting the latest advanced processes like ordering from a customer portal that initiate automated provisioning, and even event-driven procedures that initiate automated ordering through an open API. Another important point is the turn-up time. With network as a service, we are improving the provisioning speed from days or weeks to minutes. And finally, from financial perspective, network as a service is switching the payment model from fixed payment to the classic cloud model opens for service providers the opportunity to introduce new services. The bandwidth on demand, the ability to order new connectivity or upgrade immediately to support bursting needs like bursting applications or immediate backup. Scheduled services, the ability to plan routine bandwidth provisioning to support routing applications like data mirroring and scheduled backup. And service automation, the ability to program event-driven bandwidth provisioning for predefined procedures like virtual machine migration, disaster recovery, or maintenance. And the key ingredient for providing network as a service is to put SDN capabilities into the network. SDN is a hot topic, but I'm not talking about changing the whole network structure. With a simple SDN applications tool that I will present at the end, you can get the network flexibility, the bandwidth on demand, the bandwidth scheduling and automation, and by that gain two main benefits. One is to improve the customer satisfaction from cloud services by closing the gap between the cloud and the network flexibility and let the customer enjoy the full promise of the cloud. And second, a platform to sell new flexible connectivity services in the pay-per-use model that will increase the service provider's revenue. Now let's talk about the second challenge and opportunity, the security challenge and the security as a service opportunity. As I mentioned before, the main concern of business customers in the cloud is security. But we see very strange phenomena in this survey done with security officers in enterprises around the world. While 80% of traditional data centers are using security services to protect their data centers, only 25% protect their cloud services with security services. This is a huge gap that we need to understand the reason for it and to see how to close it and remove the main barrier for further cloud adoption. So let's start by reviewing the security in the cloud environment. We can see here a typical enterprise environment with the central office and remote data center where its private and public cloud are hosted, with the hosted services and websites, the gateway to the public internet, and the remote workers that access the enterprise system. There are many security risks here, and we can divide these risks to three main groups. Data interception, the risk of someone intercepts the communication, block it, or making use of the data. System infiltration, the risk of someone infiltrates the systems and hurt or change the data. And data exfiltration, the risk of someone takes out data from the organization. In order to protect the organization from all these risks, the organization needs many security services like encryption, DDoS protection, anti-bot, URL filtering, and many more. So there are many security services that we need to manage, and this is one complexity, but this is not the only one. We need to install these security services in many locations in order to protect all the enterprise systems. And the services must be dynamic as the cloud services. We mentioned before the flexibility and mobility of cloud services. So in order to protect a cloud service, you need the security services to be dynamic and transferable like the cloud service itself. But currently, most of the security solutions are being provided by dedicated hardware for each service with its own management tool. It is too complex for organizations to manage it. And this is one of the major reasons why the security usage in the cloud is so low. In order to protect cloud services, we need a platform that will support the usage of many security security platform for the cloud needs to be flexible to support the cloud flexibility. That means support quick installation on demand and the ability to quickly move security services from one location to another. The only platform that can support these flexible needs is NFV platform, with all the security services operate as VNFs. In that way, we can install easily new software security services on any NFV appliance and move it as needed. The second critical factor is centralized management. You need a centralized management tool first to manage the provisioning of the services from one platform. Another important factor is the monitoring. Many security services give many indications and flags. You need a tool that correlates all the security services indications and give you a holistic view of your security status. And finally, the centralized management platform should provide us big data cyber analytics on all the data collected and give the security officer intelligent, analyzed reports. So by introducing security as a service platform based on NFV and centralized management, the service provider gains the ability to offer a security service in much more flexible way. Services like security on demand, the ability to install quickly new security services and software solutions on standard NFV platform, the ability to collect the data from all the security services, analyze it, perform big data cyber analytics, and provide the security officer total view on his security status with correlated information. So by offering security as a service, the service provider will enjoy the following benefits. First, they will be able to remove the main barrier for further cloud adoption, and by that, increasing their business customer satisfaction. And also, they will have the ability to sell new flexible security services, and by that, increase their revenues. In my last part of my presentation, I want to present very quickly how ECI can help service providers to exploit these opportunities today. First, I want to introduce Elastic Cloud. This is ECI's solution for the cloud market. Complete networking solutions like the data center backbone that connects data centers, the Cloud Connect, the connectivity between the enterprises and their hosted applications in the remote data centers, and the Sun Connect, the connectivity between enterprises and their remote storage areas. These cloud networking services have important high needs, and ECI solutions have unique value propositions that meet these needs. First, the bandwidth demand in the cloud market is huge with exponential growth rates. So a good solution for cloud networking must have very good solution in terms of performance and cost effectiveness. And indeed, ECI has high performance solution with our 400 gig unique solution that can provide rate adaptive services depend on the distance of the connectivity. From 200 gig in ultra long haul to 300 gig in long haul and 400 gig in metro areas. We have also very efficient solution that reduces the total cost of ownership of the solution, like very low power consumption, high capacity per fiber, and efficient small form factor solution in terms of rack space. But this is not enough. In order to meet all the cloud market needs, ECI has two more unique solutions. The ability to offer very flexible solutions and a full suite of security services. In terms of flexibility, ECI provides the network as a service solution with our light up solution. this is a software solution that provides SDN application on top of your current network that provides you these flexible services. The Light Connect, which is our bandwidth on demand solution, Light Time, which is our service scheduling solution, and the Light Action, which brings automation to your network with event-driven programming. These services will allow service providers to close the gap between the cloud and the network flexibility. And in terms of security, ECI has a complete cyber security platform that includes hardware, the NFV appliances, the software, all the security services that are VNFs, best-of-breed software solutions that can be installed on ECI hardware and also on any third-party NFV platform. On top of that, we have our LightSec V, that is our centralized management system that gives the service provider and the end business customer the ability to easily provision and manage security services, monitor all the services, do risk analysis, and to do big data analytics on all the data collected and give intelligent analyzed reports. With these solutions, service providers can remove the biggest concern of their business customers from cloud services and raise the cloud adoption. So to conclude my presentation, ECI has a platform that enables service providers to provide these two solutions today, the network as a service and the security as a service. That will help service providers to improve very fast their business customer satisfaction from cloud services and will give them immediate new revenue opportunities. With that, I conclude my part and I pass the control back to you, Ian, for the Q&A part.
Okay, great. Thank you. So just a reminder for the audience, please, you can enter questions in via the chat capability. So if you have any questions for either of the speakers, please send them in now and we'll collate and fire them out. Well, a number of really interesting topics there. The one that intrigues me quite a bit is the whole topic of the big data cyber analytics. Is there anything more that you can share there? And, I think what would be really, really insightful is, are there some use cases or scenarios or some learnings that are coming out of this work so far?
So as I mentioned, the big data analytics is a platform with advanced machine learning algorithms that collects all the log data from the security services and the network, analyze it, and by that we gain better visibility into the user and the network behavior patterns, and this is allow us to pinpoint potential risks for immediate investigation. So this is maybe for the question asked. This is, let's say, the typical case studies that we are encountering to map. We are coming to an organization mapping the day-to-day network and user typical behavior, and then we can identify in real time some unexpected behavior from the network, from users, and gives the indication to the security officer.
Interesting. I'm sure this will evolve quite a bit as we go. Another question is, back to the encryption. You mentioned on your slide that layer 1 to 3. Wouldn't one layer be sufficient? Why do we need security at layer 1 through 3?
Yeah, very good question. Indeed, many enterprises uses currently one encryption method for protection. Usually it's layer 2 or layer 3 encryption. We recommend to have multi-layer protection by adding the layer 1 encryption. This adds more protection to the communication. First of all, because layer 1 encryption is the only method that protects all the payload and all the header information. So not like other encryption methods that you have some of your headers visible and you can understand some of the communication behavior. Even if you cannot see the actual data, you can see what is the origin and target of the communication, the volume, the size of the communication, the frequency of the communication. With layer 1 encryption, everything is encrypted, and you cannot know anything about the communication. So this is why we recommend to add the layer 1 encryption to any of your current protection methods. Another important advantage of layer 1 encryption is its ultra low latency and low overhead features. So in certain applications where in latency sensitive application, like for example financial trading, where the latency is critical, so the only encryption method that is acceptable is layer 1 encryption, because it's the only protection method that protects the data with no overhead, with negligible latency. So yeah, we recommend to use a mix, a multi-layer protection, and of course depends on the application demand.
Okay, just a reminder for the audience, yeah, please continue to send your questions through. So a couple of quick ones here that I think are directed a little more at OVUM. So one is, do you have another Enterprise Insight survey underway? And the answer is yes, it's actually ongoing right now. We hope to have that published in the second quarter. And then the other one, a little more in-depth. You mentioned that these next-gen data center architectures are not only going to go into the greenfield, but also be retrofitted into existing data centers. Can you elaborate on that phenomenon a little bit more? And yeah, that's what we are hearing and what we do expect to happen. And it's a bit of a different mindset, than we see in the traditional world. These types of folks do move very, very quickly. So what we're hearing is the intent is to keep data centers up, but work through in a hall by hall, room by room way, and replace servers with a new generation of servers. So go from the older 10 gig port and less dense configuration to the higher port speed and more dense configuration, and that we can see happening in kind of a 3-4 year kind of time frame. And when you think about the scale, that if they do pull it off, it really would be an impressive feat, and it would have a real step up in bandwidth on the network. Okay, so another one that we have, and this kind of continues on with the backbone question. So is network flexibility relevant only to the business cloud connectivity part of the equation, or is it also relevant in the data center backbone?
Yeah, so this is another good question. Everybody talks about, and even I mentioned, the flexible needs in terms of the enterprise, the cloud connectivity needs, and looks at the data center backbone interconnect as fixed high-performance connectivity. But we see that this is not the case. There are many dynamic, on-demand, scheduled needs between data centers, the same way that we can see in the internal data center needs, where data center needs immediate migration of virtual machines. So it's not only inside the data center. Virtual machines, a lot of time, are being migrated to another data center in case of a failure in one data center, or immediate backup to another data center, or data mirroring. So we see a lot of dynamic needs, even in the data center interconnect, even in the connection between data centers. So let's say the subject that I described in my presentation is relevant also to the connection between data centers and, of course, between data centers and enterprises.
Okay, here's another flipping back to security. So what technologies and what ways does ECI provide security for optical and or packet links?
So for the communication itself, to protect the communication, first of all, as I mentioned, there's several types of the encryption protection services that we offer, the layer 1, the layer 2, the layer 3, combination of these 3 encryption. So this is the basic communication protection that we offer. Other protection services that also relates to communication is network anomaly detection, to all the time to monitor, as I mentioned in the big data cyber analytics example, to monitor, to collect data about the network activity, and to investigate and to search for anomaly instances and alert the security officer. Another is the DDoS protection, other solution for protecting connectivity. So these are the major security services for connectivity.
Okay, great. So we're coming up close on time here. So for the audience, kind of a final opportunity to fire in a question or two. I have another one here, and this is an interesting question, and it's getting a little bit of a chuckle out of me. So optical power is insignificant compared to servers and storage, correct?
Well, maybe if you compare the amount of servers and switches versus the optical product in data centers, yes, so you have much more servers than the switches, but it doesn't mean that the optical product power consumption is not important. We know that data center operators are looking for the lowest power consumption on any product they put into the data center. If it's the servers, the switches, the storage, and also all the communication product and other. So the data center operator is, as you mentioned in your part, is a critical issue in data centers. So they are really looking for the lowest power consumption in any product they put into the data center. So this is why we are focusing also with our solution to have the lowest power consumption with our products.
Okay. Here's another one, shifting gears a little bit. So for the CSPs, what is the optimized way to incorporate these network changes due to data centers? And considering that most CSPs have an incumbent network and an installed network architecture, what's the best way to refocus on this? Their networks were essentially built for a central office world as opposed to a data center world. I'll take a first pass at this one, and Gilad maybe jump in. Yeah, this is it's absolutely a challenge for folks, and it's non-trivial to extend fiber to new places and new territories. What we often see is when the large-scale data centers are being commissioned, there's usually an early planning phase, and in that planning phase, the folks that are considering the data center, they take a look at a few things. They take a look at power. What is the power situation in the area, and they also take a look at fiber routes. And so then there's all how far away is the fiber, and is it a small lateral to get in there, or is it a much more intensive effort? And you have to consider diversity as well. There's got to be a diversity in terms of geography, and they also like a diversity in terms of more than one provider. So I think really it's about kind of getting in on the ground floor of these discussions and being in a position to say where you can help and where is something that's really too far off your footprint for you to effectively get there in a cost-effective manner. But it's non-trivial, and yeah, just to kind of jumping in on the planning phase is probably the most expedient way to go about it.
Yeah, and I agree. First of all, communication service providers has a lot of challenges from all over, and also here in the data center area, they have new competition or new players that takes dark fibers and want to build their own network. But again, and I think that in my part, so I suggested or offered communication service providers, the ability to meet this challenge and to offer services that others cannot. So this is something that enterprise or data center operator, let's say, to offer the flexible connectivity services, like I mentioned. This is something that communication service provider, if we will start to offer it, I think that he will be able, let's say, to stop this trend or maybe lower the trend and convince customers to stay with his services because of the uniqueness of the services that he offers them. The same way that enterprises and customers goes to the cloud services. Again, they appreciate the services or the benefits of cloud services, the flexibility, and in the same way, they will appreciate differentiation, different services from service providers that they cannot get by their own. So this is something that can benefit service providers.
Okay, we are coming up on time here, so we'll close with one final question here. Can you elaborate on how to start deploying SDN functionality now?
Okay, so yeah, as I mentioned, SDN is a big topic right now. Everybody is talking about to go to SDN, to put SDN controllers in the network. And this is our approach also. We are developing our own SDN controller, but let's say we are offering with the LightUp platform that I presented a quick path to the SDN area. So until the SDN technology will be proven and everybody will adopt it, it depends on a lot of vendors adopting it. So we are offering the LightUp platform that can work over the existing network of the service provider and offer this SDN application immediately, like the application that I presented, the bandwidth on demand, the bandwidth scheduling and automation. So this is something that you can implement right now over the existing network, and you get the SDN benefits immediately.
Okay, great. Thank you. Okay, well, we've hit time here, and with that, I would like to thank the audience for your attention and for listening to us today, and thank you for attending the ECI OVUM webinar. Thank you, and have a good day.
Thank you very much.